In this final video, we will be learning advanced streaming analytics techniques to handle late data arrival, exactly once processing, data archiving and on-demand replay. Welcome to part 5 and the conclusion of the series in which we are building a real-time gaming leaderboard application using Apache Flink. Let's get right into it. Let's understand how late arrival of data can impact your business logic and the outcome. Imagine at some time in future T5 player 3 data arrives as speed 120 and what you have already stored in Redis leaderboard is the data what you see on the screen. Now imagine the data in the past comes back to you with timestamp T1, player 3 and speed is 210. What you will do in this case is either of two options. First you process this data or you reject this data. Let us say if you decide to process this data, in this case you update the speed from 120 to 210 and because you updated the leaderboard after probably the race has finished, it is not going to give a nice experience to the users who have already seen the old leaderboard. Another option, if you reject this data which came in the past, maybe you make player 3 unhappy about winning the race. So when it comes to the late data arrival, what are the different options to handle this? First one is, as usual, you ignore the late messages and skip it simply because they were late, or you can process it and somehow backfill it, and this goes to the business decision. By default, the behavior is to reject such messages and filter it out. In our case, we will be using process it and apply the backfilling option, and we will see that in detail. Next one, let us understand how the duplicate messages can impact your results. Imagine in this case we are having a leaderboard of a total distance. At time T1, player 3 has traveled distance of 20 kilometers and the leaderboard looks like this. Once you process this data, you update the player 3 from 120 to 140 as this new distance traveled 20 is accommodated in the leaderboard. For some reason, due to bad networking or problem in network, you receive the same event again with the player 3 data as 20 at again timestamp T1, which is exactly the same data, but it arrived to you because of the retry. What you do is, if you decide to process it, you add up this 20 value into player 3's record and make 140 to 160 where you shouldn't. And actually because now player 3 has even traveled 140 kilometers as a distance, but it pretend like 160, you have an incorrect leaderboard. Let us understand how you can use the query that you see on the screen for the data deduplication. In this query, we are using the row number feature and we are using order ID as a partition key, which is the guarantee for the uniqueness. Once you apply this logic, you can filter the data by row number equal to 1 and depending on the latest or the oldest timestamp, which guarantees you that you process this record exactly once and you do not accidentally process this twice to produce incorrect results. Now you know how to handle the late arrival of data and achieve exactly once processing using the data deduplication technique. Let us see how you can use Kinesis Data Firehose for archiving the data and notebook to replay it on demand as and when you need to reprocess the data. So in this case, we go to the GitHub and take the checkout of branch 5, which is archive and replay setup. In my case, I already have taken the checkout. As you see, it is very simple. It just adds a new Kinesis data stream called replay. So let us go ahead and see what exactly it does. So here the idea is you already have the Kinesis stream events. You create a Firehose, which we will see in a bit, which loads the data into S3 bucket as it comes to archive for longer term. Then you use the notebook to replay that data, read from S3 and push it to this replay Kinesis data stream. That is the one we are deploying. So now let us go to the terminal. As you see, I am already in the branch 5 infra folder. I will run cdk deploy. Let us wait for this to deploy. If you have any questions, please post it in the comment section and I am going to reply to them. Once you have the CDK stack deployed, you go to the notebook. What you will see in the notebook is we need to cover first section we need to cover is the late arrival of the data, which we are already covering with Z add and Z incr by operation. Imagine you receive the data late. These commands are already going to backfill the table for you. Now, the challenge for you is to do data deduplication. I have already shown you the row number query. You could use the row number query here to deduplicate the data. Also, you can use this link to refer the query. Just make sure to use event time and player ID, which forms the uniqueness on the join query. So, the idea here is to deduplicate the data after you have joined them. Next one, we go to the Kinesis data Firehose console to create a delivery stream or Firehose data stream for archiving. So, on the source you select Kinesis data stream, on the destination you select S3, for the source you select the events as a source, it will automatically generate some name. You browse the bucket, you can leave the transform option as is because you do not want to convert the format of the record. In my case, I have already created the bucket. If you have not created the bucket, please create new one and then choose the bucket. Here in my case it is leaderboard demo 001. So, I select the bucket, then dynamic partitioning, I will turn that on. What is dynamic partitioning? Dynamic partitioning is the feature which allows you to look into the message and then use that message data to partition the folders in the S3. In our case, we would like to partition the data by year, month and day by looking at the event time field from the message. I will enable the new line delimiter as well, which converts JSON into JSON-L format, basically all the JSON separated by line. Inline parsing for JSON, I will enable that as well. Here is a quick example of how that works. It uses the JQ expression behind the scene. So, imagine you have this event as I selected. JQ expression dot customer ID is going to look into the root level and then the customer ID column and fetch this value for you. So, in this case it will partition by customer ID. Now, let us go to see our format of event table. In our case, we would like to use the event time and also the year, month and day. So, let us create the JQ expressions for the event time. So, first expression would be year. I will start with dot event underscore time, pipe operator to continue the processing and then cut the first 4 character 0 to 4, which essentially gives us the year 2023. I will add one more dynamic partition key called month, same expression, but the key starts from 5 instead of 0 and ends at 7, which gives me the second 2 character 08 in this case. Same thing for the day, just that we start with 8 and end at 10, that gives me the last part, which is the day. Now, let us write the S3 prefix. So, we will be using partition key from query. So, I will go for the Hive style partitioning, year equal to exclamation, then partition key from query, colon, and then I can use any of the key which I have defined above. So, year, then slash to create a folder, same thing again, but this time with the month key. So, I will replace month instead of year, again same thing, replacing year with the day, and that is it. It is going to create year, month and day like 3 partition. Then for the errors, if you have any errors, error should go into the errors folder. So, I will create a new folder called errors. Last one, we open the buffering hint, and then I will change the default setting from 300 seconds to 60 seconds to make it faster for the demo. You can leave it 300 seconds if you want, no compression, and then create the delivery stream. It should take couple of minutes before delivery stream comes up and starts pushing the data. So, we will switch to the notebook while it is creating. In the notebook, you have the new table now called S3 source, which essentially has the same schema as the event table. The only difference is it is using the connector called file system, which refers to the table or the files in S3. You can use any S3 path here, which could be at bucket level, year, month, day, or even the file level. Format will be JSON. You can use the query called select star from S3 source to validate that you can read the data from S3 folder. This is the path where Firehose is going to dump the data. Now, we have a new table called replay, which points to the replay stream, and the challenge for you here is to read the data from S3 and then write it to the replay. You already know how to apply the leaderboard logic on now replay table. You can replay the data for past week. We have already ensured that using the data generator, we generate the data for past week. Thank you for watching this video series on building a real-time gaming leaderboard application using Apache Flink. Over the past 5 episodes, we built real-time analytics leaderboard for a car racing game from scratch and applied advanced analytics techniques to achieve dynamic config with zero downtime and replay of on-demand data. I would recommend going through all the links in the reference section, which is in the video description, to continue learning more about streaming analytics best practices, how to do scaling and monitoring, automated deployment and version update, and more. Thank you so much for your time and happy learning.